Solve this equation for 5 marks again. When you look at this log equation, Elijah, what do you need to consider? What do you notice? They have different bases, but what do you notice about the different bases? Not multiples, powers of 2. Log got nothing to do with multiples. So they are all powers of 2, right? In other words, if they are all powers of 2, what do? I change all of them to the same base. But which base should they become? They should become base 2. Now, you can choose to bring the 3 upwards, meaning to make it become the power, or you can just choose to leave the 3 alone. Because if you choose to leave the 3 alone, right, it's just multiplied by 3. The 3 is a coefficient. It doesn't really affect anything. Okay? So up to you. So I will make all become base 2. You should make them become the smaller number, not the larger number. So this will give me what? Log base 2 x minus change of base. I have log base 4. So your base will always become the denominator, right? So this will become log base 2, 4. Right? And then numerator log base 2, x plus 3. Okay? Then your right hand side, the 3 can keep as a coefficient. So log base 2, 8 will become the denominator. Then your numerator is log base 2, 2. You can do it to just simplify it down to 1. Not wrong. You bring the 3 up, then it becomes 2 to the power of 3, which is 8, right? Then it's log 8, 8, then it becomes 1. Either way is fine. If you can see it that way directly, you can do that. All right, but either way, the answer will end up becoming 1, as you will see. So log base 2x minus log base 2, 4 is 2, right? You ought to be able to directly tell me this is 2. Then this is log base 2, x plus 3. And then this is equal to... the reason why I don't want to do that, you can make it become 1. It's not wrong. But specifically... Okay, it actually doesn't matter. So here you will get 1 over 3, right? Either way, you will get back 1 over 3, which you should know is 1. Right? But that's not the important thing. First thing that I want to do here is to multiply both sides by 2. Why? Because I want to get rid of the denominator. I always want to get rid of the denominator. So if I get rid of the denominator, now I have log base 2, 2 log base 2x minus log base 2 x plus 3 equals to 3 times 2 is 2. Now, this is where it gets a little bit interesting. This is where it gets a little bit interesting. From here, how will you continue? Eileen, do you get this? Or you did it in a different way? Huh? You did it in a different way. What do you do? You made it equal to 1. And then? Oh, you make life a lot more difficult for yourself, but sure. Okay, up to you, like. Sure, if you prefer the square root at the bottom, up to you. So what Eileen did is out of 2, right? So means times half, right? Times half means you move the power up, it becomes x plus 3 to the power of half, which I don't want to deal with. That's why I put it this form. And then from here, I will get log 2x squared minus log 2x plus 3 is equal to log 2 to the power of 2. Correct? Because 2 is the same as 2 log 2, 1. It's the same exact thing. It's just that you choose to leave the half. I choose not to leave the half. But either way, you will square it, right? And then I don't need to square it now. It's the same exact thing. And therefore, now we have log base 2. X squared minus is divide, right? So over x plus 3 is equal to log base 2, 4. And therefore, x squared over x plus 3 is equal to 4. Okay? In log, this is called your argument. Okay, this thing over here is called the argument. So what we are doing here is comparing arguments, but you don't need to write that. Okay, and you will have x squared equals to 4x plus 12, and therefore x squared minus 4x plus minus 12 equals to 0. So either way, we end up back with the same quadratic equation. And then from here, you will have x minus 6, then x plus 2 to give me this, and therefore x is equal to 6 or x is equal to negative 2. But double check, can x be negative? No, because we got log 2x, right? So x cannot be negative, and therefore you will reject this. And therefore there is only one solution. So anytime you solve a quadratic in terms of log, always double check whether there is how many solutions are acceptable.